Okay, children.
Yes, ma'am.
Let's regroup. Make sure you have the guided notes out. Put your name at the top of them, and we are going to get rolling. Today, we are doing Unit 3-2, which is the complex number system and imaginary numbers, okay? So the first, what we ended up spending, I think like 5 whole days on Unit 3-1. It was just over factoring. You know, we had to take an extra day to review and then take an extra day to retake the quiz. So today we are moving into Unit 3-2. What?
Oh, yeah, that's my bad. I wasn't here Friday.
You need to take it tomorrow.
I need to go to the doctor.
Okay. So Unit 3-2 again is over the complex number system and imaginary numbers. Make sure you have your name at the top of your notes. We're going to go ahead and get rolling just because a majority of class will be spent on the actual notes themselves. We have 3 objectives today. Somebody read objective number 1.
I can write complex numbers A, B, I, and the difference between the real and imaginary term complex numbers.
Perfect. Somebody read number 2.
My bad, go ahead.
No, I got it.
I can
relate to imaginary numbers and complex numbers.
Perfect.
I can perform operations with imaginary numbers and complex numbers.
What's up?
Perfect. So these are our 3 objectives. I know they look like a lot, but honestly, first period did good with this lesson once they stopped trying to overthink it. So I don't want you to overthink this lesson. Okay, just take it as it is, and I promise you it'll click. So for the first 30 seconds of this lesson, we're just going to talk about the complex number system. The complex number system is something that probably was mentioned to you in Algebra 1. And even if they didn't specifically tell you, oh, this is the complex number system, that's what it is, okay? Complex numbers can be broken down into real numbers, okay? So all numbers are complex numbers, but they can be broken down into real numbers. Real numbers can be broken up into irrational and rational numbers. Rational numbers can be broken up into fractions and integers, okay? Integers can be broken up into negative and positive / whole numbers. And then lastly, positive and whole numbers can be broken up into 0 and natural numbers. And natural numbers are like our counting numbers, okay? Go ahead and flip over. Now, up until this point, that's all you've known. You've only worked with real numbers. But there is another category of complex numbers that we will introduce today, and those are imaginary numbers, okay? Now, I want you to make a little note here that all numbers are complex numbers. So all numbers are complex numbers. Oh, wow, why is it doing
I
that?
can't read that.
I'm fixing it, just chill out. So all numbers are complex. So any number you see today and any number you see ever is a complex number, okay? But we have 2 subcategories of complex numbers that numbers can fit in, and that is real numbers and imaginary numbers. So in your little box, I want you to fill in imaginary numbers, okay? That's the whole focus of today's lesson, is introducing you all to the imaginary number system. Again, do not overthink this lesson, because the less you overthink it, the better you're going to understand. I'm going to give you a second to get that down. Once you have that down, put your pencil down. But just as a reminder, okay, make sure that every single person in this room is writing down every single thing that I do. Remember, you don't have the option to just sit here and watch me write.
Yeah.
Yeah.
See, they stay targeted.
I mean,
You did too.
I was calling you out without saying your name. They just were the ones that decided to say your name.
Yeah.
Because on Thursday, you're the only one that wasn't taking notes consistently.
Okay. I've been the only one taking notes.
On Thursday, you were the only one that wasn't consistently taking notes. Make sure you write things down. Now, as I'm reading this, you just be filling in the blank. So all complex numbers can be written in the form A plus BI, with A being our real part and BI being the imaginary part.
It is a what?
So all complex numbers are written in the form A plus BI. Anytime we have complex numbers that have a real part and an imaginary part, that is how we will write it. And it's simply just saying you're going to put the real part first and the imaginary part second. So if, for example, I give you the complex number -10 plus 8i, this is an A plus BI part, with -10 being the real part, meaning it does not have an I, and 8i being the imaginary part.
Okay.
And I'm going to abbreviate imaginary part a lot today as IMAG. Okay. Now, building off of that, I is the imaginary unit that exists such that I squared equals -1. I want you to put a circle around this, or a box, or a little cloud, or whatever, because that is one important fact that we're going to talk about today. There are technically 4 important facts that we're going to talk about today, but that's one of the key ones, and we're going to come back to it. Okay? But again, I is the imaginary unit that exists such that I squared equals -1. Now again, for these bottom 2 bullets, I want you just filling in the blanks. So if you have a complex number where the imaginary part is missing, then it is a real number. Okay? So again, all numbers are complex numbers. However, if you're missing an imaginary part, we refer to that number as a real number. On the flip side, if you have a complex number that is missing the real part, okay, we refer to that as a non-real number, and it can be classified as a pure imaginary number. Okay? Once you have that down, I want you to do 2 things. First, put your pencil down. Second, flip over to the next page. So again, if you have a complex number that is missing the imaginary part, we refer to that as simply a real number. Whereas if you have a complex number that is missing the real part, we refer to that number as non-real, and it can be classified as a pure imaginary number. Okay? Let's keep going. I want you to make a note that this is like homework number 1. Homework number 1 literally has a table just like this. Okay? Now, in this table, we are given 4 complex numbers, okay, because all numbers are complex numbers. And it wants us to decide if it's real or non-real, what the classification would be. It wants us to write it in A plus BI form. Hey, Evan. Put it flat down. We don't need a calculator probably at all hardly today, so flip it over. Then we're going to write it in A plus BI form. And then lastly, we're going to identify the real and imaginary parts. Now, when you're classifying a number as real or non-real, you are going to look for I. Okay? Now, just as a little heads up, because on number 1 on your homework, the last one has I squared in it, you will have to fix that how we're going to later in the lesson. Okay? So, N7 plus 84I, would we say that is real or non-real?
That's fake.
It's non-real because we have an I in there. So since it has an I, that means it is non-real. Now, if you want to put the little hyphen in non-real, that's okay. On the EOC, they just write non-real without that little dash, so that's why I'm writing it like that. Now, since it has a real part and an imaginary part, this number is just a complex number. So for the classification, we're going to write complex number because it's made up of that real part and that imaginary part. We see both parts. So that is a complex number. Now, for this first example, it is already in A plus BI form because remember, A means real part first. BI is imaginary part second. So this number here is already in that form for us. So 7 plus 84i. And then the last thing we're going to do is we're going to identify the real and imaginary part. So for each of these boxes, we're going to put real, and then I'm going to abbreviate imaginary. In 7 plus 84i, somebody tell me what's the real part?
7.
7. What's the imaginary part?
84.
84.
I'm going to put 84i. If you put just 84, just know that I'm not going to count that wrong because I know exactly what you're talking about. But technically, the imaginary part is the 84i. Okay, let's keep going. So for the second one, we have negative 9i minus 4. Alyssa, would you say that is real or non-real? Non-real, because again, Yasir, what are we looking for when we determine if it's non-real or real? The I. And if it has I in there and it cannot be simplified, it is non-real. Now again, since we have a real part and an imaginary part both present, it is just a complex number. However, is that in A plus BI form?
No.
No, Tapacia, how can I rewrite that in A plus BI form? Perfect. Negative 4 minus 9i. Because you'll notice that Tapacia put the real part first, the imaginary part second. Now, building off of that, Javon, what's the real part?
Negative 4.
Negative 4.
You're smart.
And Kara, what's the imaginary part? Perfect. Negative 9i. Notice here that Kira pulled the minus with it. In first period, they said non-i, but it is negative 9i because the minus goes with it. Okay, let's keep going. Looking at the third row, we have 23. Would you guys say that is real or non-real?
Real.
Real, because do we see an I?
No.
No. Now, since it does not have an imaginary part, we're going to classify this as a real number. Now, if you're asking yourself, because I had a couple of first period kids ask this, didn't you say all complex numbers or all numbers are complex numbers? Yes. So if you want to write complex / real, I am okay with that. However, if you put just real number, I'm also okay with that. Okay. I'm going to put real number just because that's what I did in first period. But again, if you want to put complex and real, I'm okay with either one. You just cannot put just complex. Okay. Now, you guys told us, or told me, that we're missing the imaginary part. But in order to write it in A plus BI form, we still need to have an imaginary part. So I can write this as 23 plus what?
1i.
Alright.
0 BI.
0 what?
BI.
Close, just 0i. So if you're missing the imaginary part, you're going to put a placeholder of 0i. Now, the reason why we're not putting just I is because if we have 23 plus I, that's a whole different expression from 23. But right here, you'll recognize 0 times I is 0, and 0 plus 23 is 23. So this is still equivalent to our original given number. It's just written in A plus BI form. So, Brandon, what's our real part in this? 23. Madison, what is our imaginary part? Perfect, 0i. Okay. Now, using that same thought process, let's work through the final one. So for our final row, we are given 3i. Would you guys say that is real or imaginary?
Imaginary.
Or just kidding, real or non-real?
Non-real.
Non-real.
Because she said real or imaginary.
I know, I didn't know that.
Even though it is imaginary.
Yes, that on the EOC, I noticed this summer that they specifically use real and non-real. So that's why I include that in this lesson. Now, it is a complex number. However, since it's missing its real part, we can also classify it as what?
0.
No,
Pure.
pure imaginary number.
Oh, I thought you were talking about the number.
No. I'm going to come back to you though. So this is a pure imaginary number. Again, if you want to put complex and pure imaginary number, again, I'm okay with that. But the classification that I have to see is this, because yes, it is a complex number, but it has a special classification since it's missing that real part. Now, let's go back to what Evan was saying.
That's me.
How can I rewrite 3i in a plus bi form?
0 plus 3i.
Perfect. So 0 plus 3i. Okay.
And then you would put the real 0.
The real is 0.
Imaginary 3i.
Perfect. So the real part is 0. The imaginary part is 3i. Once you have this down, put your pencil down just for a moment. Shh. Once you have this down, put your pencil down just for a moment.
Are those broken in yet?
They don't speak anymore.
You wanna know
I
what
think so.
Javon just called me?
Why are you laughing?
He's got this smooth thing. He's got a
Brittany said at least now that Javon's back, you won't be talking to yourself. Or to the computer. Okay, everybody ready? Let's regroup. Let's come back. Come back. Come back. Okay, let's look at this one. Now, again, this is about building to where I'm going. Okay, what do each of the following equal? We can rewrite 2 to the second power as 2 times 2, which equals what?
4.
4. We can rewrite -2 squared as -2 times -2,
4.
which still equals 4. 0 to the second power can be rewritten as 0 times 0. Let's keep using that logic. How can I rewrite 1 over 10 to the second power?
2 over 20.
1 over 10 times 1 over 10. We've mentioned this a couple times in class, but when we multiply fractions, we multiply straight across. So 1 times 1 is,
Oh, it's 1 over.
yeah, 1 over 100. Okay, let's look at this last one. -3 over 5 to the second power can be rewritten as -3 over 5
Times,
times -3 over 5.
which would equal
What?
-9 over 25.
9.
Close.
9 over 25.
Negative times a negative is a
Oh.
positive. Now, I breezed through that pretty quickly just because there's a key concept that I want you to get from this. What do we notice about all the answers?
They're easy.
We notice they're all what? They're all positive.
Oh,
Even though 0 does not have a positive or negative, still, you get the idea. Okay? Based on that, it seems like squaring any real number will always give us a positive answer. If you notice, 2 squared give us 4, but -2 squared also gave us 4. Okay? What about imaginary numbers?
no.
If we take I squared, we can rewrite that as, yeah, go ahead and flip over.
Does I mean imaginary?
If we take, we'll give you guys a minute. If we take I squared and we rewrite it as I times I, we know it equals -1. Now, if you're like, okay, well, where does that come from? This is one of the key facts that I told you in that third slide, that I squared equals -1. Okay, that's a key fact that we need to know for EOC for this lesson. It's specifically part of our standards for today. I squared equals -1. Now, working backwards from I squared equals -1, we can solve this for I by taking the square root of both sides. And that shows us that I equals the square root of -1. Because if you don't know, if I have I squared equals -1 and I say, hey, solve that equation, you solve that by taking the square root, and the square root of I squared, similar to what we said last week where the square root of x squared was x, the square root of I squared is I, and that equals the square root of -1. Now, if you're sitting here thinking, well, isn't the square root of -1 -1?
No, positive one.
It's not. It's not.
It's
It's not
not.
negative or positive.
It's not an answer.
Because we have learned in the past that you cannot take the square root of a negative number. And that's where the whole idea of imaginary numbers comes from. Okay? Bye, Katie.
Bye, Katie.
By accepting, I'll give you guys a second. By accepting that I exist, we can now solve things that need the square root of a negative number. Because again, up until this point, you've been taught you cannot take the square root of a negative number. It's not real. If you go on your calculator, which the phones do it a little bit different, but if you type the square root of -9, it should say non-real. Now again, for the phones, they may give you the actual answer. But let's look at this.
It says 3i.
Yeah, that's what it says for me too.
Like I said, the phones automatically generate this. Now, again, up until this point, you've been taught you can't take the square root of -9. However, using the concept of I, we can rewrite the square root of -9 as the square root of -1 times the square root of 9. Based on what we wrote in the last slide, what can I replace the square root of -1 with?
Hold on. I'm thinking.
With I, okay? Again, the square root of -1 is I. And what's the square root of 9?
3. Oh.
3.
Oh, yeah.
Now, even though I is an imaginary unit, and you're gonna hear me say this a ton today, you're gonna treat it like it's a variable. So somebody tell me what's I times 3?
3i.
3i. So the square root of -9 equals 3i. So in general, if you have the square root of -x, with x being any number you can think of, we can rewrite that as I square root of x. Using that little, it's not really a formula, but still, using that, let's take the square root of -81. If the square root of -x can be rewritten as I square root of x, we can rewrite the square root of -81 as I square root of 81. And somebody tell me, what is the square root of 81?
God.
So we can write this as 9i,
I get it, but I don't.
okay?
So basically,
So-
what you're saying is the I can go in front of everything.
Yes.
And then it'll end up getting put behind it. Though.
When you have, because you write it coefficient first. Anytime you take the square root of a negative number, you take the negative out, put I up front, and then simplify your radical. Okay, we're gonna see this whole concept multiple times this week. Once you have this down, flip over and put your pencil in.
Are we supposed to have that, or do we just write it down?
Then you do what you have to say.
Yeah, you're on
No,
one.
like, were we already supposed to have that part?
This, no, if it's not written, no.
No, we don't have it.
Hey guys, on your paper, this is not written, so I want you to write it if you didn't.
You want us to write it?
Yes, I do want you to write it.
Oh, I thought you said we don't write it.
No, you do. Now you got a second, so you're still writing. Okay. Let's look at this. Now, we're going to continue using the fact that I squared equals -1 to figure out what is I to the third and I to the fourth. These are our other two important facts that you need to know today. Now, I to the third can be rewritten as I times I times I. Now, if you're thinking to yourself, okay, well, she said I equals square root of -1. Yes, but you're never going to replace I with the square root of -1. Okay, you're going to leave I as I. However, since we have two I's here, we can rewrite that as I to the second times I. Okay, you're gonna see where I'm going with this.
Hold on.
Why can't we just make it I?
What? because you're gonna see just hang tight. What did we say I squared is equal to?
One, negative one.
Negative one. Those of you that said negative one, that's right. So I can write this as negative one times I. And again, thinking of I as a variable, what is negative one times I?
Negative one off.
Negative one I or just negative I. So another one of your important facts, which I want you to write a box over here. And I want you to put I squared equals negative 1. And now we know I to the third equals negative I. Okay, because again, you're not replacing I with anything. Anytime you see I squared, you're replacing with negative 1. Anytime you replace I to the third with something, you're going to put negative I. And now, let's figure out what I to the fourth is. So I to the fourth can be rewritten as I times I times I times I. Okay? We have two groups of two I's. Okay? I times I can be rewritten as I to the second. I times I can be rewritten as I to the second. And again, anytime we see I to the second, what are we replacing those with? Negative 1. So if I replace both of those with negative 1, what is negative 1 times negative 1? 1. So I to the fourth equals 1. I want you to put a star beside this box. Again, anytime you see I, you're not replacing it with anything. But anytime you see I to the second, you're going to substitute negative 1 in for it. Anytime you see I to the third, you're going to substitute negative I in for it. Anytime we see I to the fourth, we're going to substitute 1 in for it. Okay? This is something that you have to have memorized. Okay? Now, you'll memorize it as we go because we're going to use it quite a bit today, but make sure that you know those. Okay? Now, sometimes you're going to be given I with higher exponents than 4. Okay? When you are given I with an exponent greater than 4, there is a trick figuring out what it is it equivalent to. Okay? In general, if you have I to the nth power with n being some exponent, some number, okay, it is going to equal I to the r power, where r is the remainder of the number n when divided by 4. Now, we're going to evaluate I to the 7th, but then we're also going to add an extra example because this skill right here is the one that I saw first period struggle with. So we're going to add another one, and we're going to do I to the 81st power. Okay.
That's crazy.
I like that.
So in order to evaluate I to the 7th, we're going to take that exponent of 7 and we're going to divide it by 4. Now, how many times can 4 evenly go into 7? Once. Okay? So hopefully you remember we put 1 up top. You multiply that by 4. You're subtracting it. And our remainder would be what? 3. I want you to make a note that that's your remainder.
I'm confused.
Hold on. Now, the reason why that's important is because now we know that I to the 7th power is equal to I to the 3rd power. And we said on the last slide that I to the 3rd power is equal to what? Negative I. So I to the 7th is equal to negative I. Okay? Yes.
I'm so confused.
Okay, well, watch the next one and actually focus all your attention on
No,
it.
it ain't that. You said we was gonna do I to the 81st power and then we're 4 and 7.
I said this is going to be an extra example that we do.
So we're not doing that yet.
We're about to do it.
Okay,
I just
so we
said
was
that
doing
first
one.
period struggled with this concept, so I wanted to add an additional example.
Okay, I know what we're doing. I
Okay.
didn't know we was doing first.
Now, let's do the same thing. To evaluate I to the 81st power, we're going to divide 81 by 4. Now, if you're asking yourself, well, are we always going to divide by 4? Yes, because I had a couple people in first period ask that question. It's always by 4 because that's the trick to figuring it out. Okay, 81, okay, how many times can 4 go into 8?
One.
2. Okay, so we're going to bring 2 times 4 is 8. That gives us 0. Bring down your 1. How many times can 4 go into 1?
0.
0 times. 0 times 4 is 0. So our remainder is 1. So that means I to the 81st power is equivalent to I to what power?
First, not just.
Yeah, the first power. And anything to the first power is just
I.
itself. So it's going to be I.
So what you're saying is I to the 81st power equals I.
Because the trick is to divide that number by 4, figure out what your remainder is.
Low key, yes.
Now, let's bump it up a notch. Beside of this bottom example, I want you to put HW number 2. Because homework number 2 is like this one. So it says evaluate I to the 17th power plus 2I to the 15th power plus 3I to the 12th power. Now, when you're doing problems like this, because homework number 2 is like this, start by evaluating each of your i's, okay? So evaluate each of your i's. So let's figure out what I to the 17th power equals. 4 goes into 17, how many equal times?
4.
4. 4 times 4 is 16.
With the remainder
We
1.
subtract 1. So I to the 17th is equivalent to I to the 1 power, which is I.
That's crazy.
Okay? We're going to come back to our expression, but let's just evaluate the i's. If I have I to the 15th power, 4 goes into 15 how many times?
4 goes into 15.
3 times. 3 times 4 is 12. We get a remainder of what?
3.
So I to the 15th power is equivalent to I to the 3rd power, and
Which is
I to the 3rd power is negative I.
So negative.
Okay?
So I plus
Hold on.
negative I.
Let's do the same thing with I to the 12th. Let me scroll down possibly. There we go. So we're going to do the same thing with I to the 12th. 4 goes into 12 how many times?
3 times.
3 times. 3 times 4 is 12. Gives us a remainder of 0.
So that's
So I to the 12th equals I to the 0 power. And anything to the 0 power is what?
this right? 0.
Anything raised to the 0 power is what? 1. So I to the 0 power equals 1. Now that we know that I to the 17th power equals I to the 15th power equals negative I, and I to the 12th power equals 1, we're going to replace each of those in our expression with what it's equivalent to. So I to the 17th
Wait, I have a question.
is I. Yes.
Are we gonna do anything with the coefficient?
That's what we're about to do. And then Javon's asking, what about the coefficients? We're going to bring down that plus 2, and we're going to substitute negative I in for I to the 15th. Then I'm going to drop down that plus 3, and I'm going to substitute in for I to the 12th, 1. And then at this point, you're going to multiply those coefficients with what we got. So we're going to drop down the I. Again, thinking of I as a variable, what's 2 times negative I?
Negative 2I.
Negative 2I. 3 times 1 is
3.
3. Now again here, thinking of I as a variable, we've got like terms. What is I minus 2i.
Negative 1i plus 3.
Negative 1i plus 3. Because again, it's just like combining like terms. If I said, hey, what's x minus 2x? You guys could tell me
So
negative x.
technically, it should be
Okay?
3.
Hold on. So I minus 2i, like Evan said, is negative I. Drop down your plus 3. But anytime we write complex numbers, we put them in a plus bi form. So how should we rewrite that?
3 minus I.
Perfect.
Hey, that's small. Little bit?
Are there any questions on this?
He said that little man was at the door.
No, it's like big anymore.
Chris?
Is that
Yes,
is
Javon.
that-
It's like, it was like, are there gonna be questions, I can't get my words.
It's okay. It's your first day back.
Yeah, right here, we was like doing this stuff. Are there gonna be questions where we have to do like that and then do this?
No. Technically on EOC, they could combine that, but
That's
for
too
this.
hard. I'm gonna do
Okay.
it.
shh. Are there any questions on this? If not, go ahead and flip over. Okay. Now, put you a little note that this is similar to homework number, hold on, I don't want to lie to you. Homework number 4. Make you note that this is like homework number 4. This is also a common EOC question. The format that this is in is common on the EOC. So it says select all expressions that result in a non-real number when simplified. I want you to underline that non-real. Okay? Now, a lot of times students look at these types of problems and they get extremely overwhelmed.
I am.
But you know my strategy. Take an answer choice by answer choice. If you work on it, answer choice by answer choice, that makes it a little bit easier. So I'm going to do these in different colors so that way the people watching the video and getting the notes can see this. But let's start with this first one. So I times square root of negative 16 times square root of negative 100. Now, real quick, I want you to flip back to where we found the square root of negative 9 and the square root of negative 81. We said the square root of negative 9 was what?
3.
3i. We said the square root of negative 81 was what?
20.
9i. Now, using that same logic, what is the square root of negative 16?
Negative 4.
So I'm going, it's just 4i. Well, don't say that thing if you don't mean it. So I'm going to replace the square root of negative 16 with 4i because again, anytime you're taking the square root of a negative number, pull the I out, take the square root of what's left over. Okay? Now you'll notice that I put it in parentheses because we have to worry about this I. Same logic. What's the square root of negative 100? 10i. Because again, that's their negative underneath there, so we have to put I. Now, I don't think we've done this yet. But if I said, what's x times x, what would you guys say? X to the second power, or x squared. So using that same thought process, what's I times 4i? 4i to the second power. Because I times I is I to the second. We have to bring down the 4. So I have 4i to the second minus 10i. Now, you can do this different ways. The way that I do it is anytime I see an I squared, I immediately replace it with what though? Negative 1. Because I to the second is negative 1. So I have 4 times negative 1 times 10i. Because I squared is equivalent to negative 1. 4 times negative 1 is negative 4. And again, thinking of this as a variable, what's negative 4 times 10i?
Negative 14i squared.
What's negative 4 times 10?
Negative.
Negative 40.
I.
Now, we simplified it. Savannah, is that real or non-real? Non-real. So are we going to check that first answer choice? Yeah, because we're looking for the non-real answer choices. Okay,
That one was low key.
okay. I'm going to do the next one in red because, again, people who are looking at the notes will probably be confused if I just write it all in the same color. So let's look at the second answer choice. We have -3 I to the second plus the square root of 9I squared. Now again, you can go about these however you want. Like I said, anytime I see I squared, I immediately change it to -1 just because that's a super important thing that you need to be able to recognize. So that's what I'm going to do here. I'm going to replace this I squared with -1, but I'm also going to replace this I squared with -1. So I have -3 times -1 plus the square root of 9 times -1. -3 times -1 gives us +3. 9 times -1 is going to give us -9. And earlier, Brittany, we said the square root of -9 was what? 3i. Can we combine 3 plus 3i? Can we combine those?
No.
No, because they are not what? Like terms. Now, is that, Arislandi, real or non-real? Non-real. And what's the thing that we're looking for to determine if it's real or non-real? The I. So are we going to check that second answer choice?
Yeah,
What type of answers are we looking for?
non-real.
Non-real, so we're going to check it. I'm going to do the next one in blue. So let's look at the next one. It has -I to the third times I to the third. Now, if you're looking at those I to the thirds and you're thinking, okay, well, let's replace them with what they are. You can do that. However, number 4 on your homework, I think the first answer choice is I to the 8th times I to the 5th. And you need to recognize that you are adding those exponents. So that's the way I'm going to do this one. A negative times a positive is going to be a negative. And since we have common bases, you're going to add these exponents. So I get I to the 6th. Now we have to figure out what I to the 6th is equivalent to by dividing that exponent by 4. So how many times does 4 go into 6? Once. 1 times 4 is 4. So I get an exponent of what? 2. So -I to the 6th is equivalent to -I to the 2nd. And what is I to the 2nd? -1, because it's always -1. So I have -1, which equals 1. Is that real or non-real? One's a real number. So are we going to check our third answer choice? No. Okay. I'm going to give you a second to get that down because I'm going to have to scroll down. I'm going to do this next one in green. Okay, I'm going to go ahead and be scrolling down. Maybe. So for this next one, we have 4i minus square root of 25i squared. Again, you can go about these different ways. But again, I like to replace I squared with -1. You're not replacing I with anything because we don't ever replace I with anything. You leave it as I. So I'm going to have 4i minus square root of 25 times -1. Because again, here we're acknowledging that I squared equals -1. 25 times -1 gives us the square root of -25. And what is the square root of -25? 5i. Anytime you have a negative underneath the square root, you have to put I, so it's going to be 4I minus 5I. And if we combine like terms here, what do we get for our simplified expression?
9 squared.
4 minus 5 is,
-1.
right, so we have -1I. Technically, you don't have to write the -1 there, but is that real or non-real?
Oh, really?
Non-real. Are we going to check our fourth answer choice then?
Yeah.
Yes. Non-real. So I'm gonna go back up here and check it. I'm gonna go ahead and change my color, but just know I'm scrolling back down. So let's look at that final answer choice. Now, if you think you can do it, I want you to go ahead and simplify it. But we have -9 plus I square root of 36I squared. Again, here you can do whatever you want because you can work these different ways. But I'm going to replace I squared with -1. So I have -9 plus I square root of 36 times -1. 36 times -1 gives us -36 underneath our radical. What is the square root of -36? 6I. Now, you cannot just write 6I because we have that I before the radical that we have to worry about. So we're going to put 6I in parentheses. So I have -9 plus I, parentheses 6I. And then what do I have to do here? What do we have to do?
Multiply I times 6I.
Yeah, we have to multiply I times 6I. And what is I times 6I, Elizabeth Ramos? Yeah, perfect. So I have -9 plus 6I squared. We're going to replace I squared with a -1. So I have -9 plus 6 times -1. That gives us -9 minus 6, which gives us a final answer of -15. Real or non-real?
Real.
Real. So are we going to check that final answer choice?
No.
No. Make sure you have the homework number 4 out the side of that one. And once you have all this down, I want you to put your pencil down. Now, one of the reasons why I wanted to give you that problem is because first, it's going to be an EOC problem. They always include one that's similar to that, and then they always include one that we're going to see here in a bit. But the other reason why I wanted to include this problem where I put it is because this gives you a chance to practice those operations with I. So I times I, we recognize as I squared. We also recognize that we can combine like terms when it comes to our I's. Okay, and that's going to make these next few problems a little bit easier. So when it comes to operations with complex numbers, and again, here you're going to just fill in the blanks. So everybody be filling in the blanks. Everybody be filling in the blanks. Yes, Kira? Mhm. When adding or subtracting complex numbers, you simply combine like terms like you would with variables, like we did in the last example, okay? When multiplying complex numbers, you distribute first and then simplify as you go, okay? So again, you're treating I as if it is a variable, but we have to remember that it's not, okay? And the key difference is just that if you see I squared, I to the third, or I to the fourth, you need to recognize, oh, I need to replace that with what it is, okay? We're going to skip over some, and if we come back to it, we come back to it. So we're going to skip example 2. Beside of example 3, I want you to put HW number 5. So like I said, we're going to skip example 2 just for the time being, and I want you to put HW number 5 out the side of this. So this one says, write the complex number negative 14 minus 6i to the second plus the square root of negative 225 in a plus bi form. Now, you can do a couple things here. Again, anytime I see I squared, that's what I start with. So I'm going to bring down negative 14. I'm going to bring down my minus 6, but instead of I to the second, I'm going to put negative 1 because, again, an important fact is that I squared equals negative 1. Now, somebody tell me if you know it off the top of your head or if you need to use your calculator. What is the square root of 225? 15. So if the square root of 225 is 15, then what's the square root of negative 225? 15i. So I'm going to put plus 15i. Because again, the square root of 225 is 15, but the square root of negative 225 means it needs to have an I with it. Okay, so make sure you realize the difference between these two. Now right here, what should we do next to simplify?
Multiply negative 6.
Right, so we're going to do negative 6 times negative 1 first, because remember, you're following the orders of operations. Okay, so negative 6 times negative 1 gives us positive 6. So I have 14 plus 6 plus 15i. And if I combine like terms, what's going to be my final expression? Negative 8 plus 15i. Are there any questions there? Like I said, this is almost exactly like homework number 5. Once you have this down, put your pencil down just for a moment. Okay. Out beside of this one, actually, we're going to skip number 4. Let's look at number 5. So go to example number 5, and I want you to put HW number 6 out beside of this one. If you feel confident in what we're doing, by all means, try this one on your own, because I think a lot of you are at the point where you can do this problem on your own. But let's look at it. So it says, write the expression negative 4i times 2i minus 3 times 5 minus 2i in a plus bi form. Again, start by recognizing, do we have anything that we need to replace? So any I squareds?
No.
No. Next, ask yourself, is there anything we need to distribute? Is there?
Yes.
What things do we need to distribute? Okay, the negative 3, I heard a couple people say that, because that's in front of a parenthesis, so that one's easy to recognize. And then what also do we need to distribute?
1.
The negative what? 4i.
Is there a 1 in front of the 2 i's? No.
I mean, an implied one, but that's not necessary for this problem. So, building off of what we've talked about, Elizabeth Fuentes, tell me, what is negative 4i times 2i? So what's negative 4 times 2? And what's I times I? I to the second, good. So negative 4i times 2i gives us negative 8i to the second, okay? Marquise, if we distribute negative 3 to 5, what do we get? What's 3 times 5? Okay, so we're going to have negative 15. And then if I do negative 3 times negative 2i, what does that give us? Close. What's a negative times a negative? Yeah. So we're going to have positive 6i, because be careful here, negative and negative gives us a positive. You recognize that we're going to get just an I. Now, what do we need to replace at this point? Yeah, with what? Right, so We're going to replace I squared with -1. We're going to bring everything else down. And then what do we need to do now that we've replaced I squared with -1? Yeah, we're going to distribute or multiply -8 times -1, which gives us +8 minus 15 plus 6i. And I want you to take 2 seconds, combine like terms, and write our final answer. Sorry. So I want you to combine like terms and write down your final answer. Give you guys just a second. Okay, so what is our final answer? Perfect. So -7 plus 6i, because 8 minus 15 gives us -7. There are no like terms with 6i, so we just bring that down. Are there any questions on this one? Yes. Okay. Let's look at the next one. Now, out beside of this one, I want you to put homework number 7. Homework number 7. Okay. Now, this is the other question that I was saying that is popular on the EOC. Specifically, I think it was like one of the first few from this past year's EOC looked like this, where they give you 3 expressions and all they wanted to know is it real or non-real? Okay. So this one says, identify whether each expression is equivalent to a real number or a non-real number. So what we're going to do is we're going to simplify each answer choice, and then we're just going to choose if it's real or non-real. Now, I write really big, so I'm going to put this on a separate slide. But if you think you can work through these, work through them. What?
So I know how you tell us we need to work out each one of them, right?
Huh?
Like each one of those, we have to work them out, figure it out.
Yeah.
But on the EOC, that's when I did it, I ran out of time.
Okay.
So then we do it out of time.
You just guess.
Okay. Oh, I guess.
Okay. Again, I'm going to do these in 3 different colors. So I'm going to start with this first one. Now, on your guys' notes, you can just work this down at the bottom, but everybody needs to be writing this down. So I'm going to start with 3 plus 3i, 3 minus 3i. Now, even though we have not seen one like this in the notes yet, somebody tell me what you think we're going to do. We're going to, okay, you can use the FOIL method if that's what you taught. But I always call it double distribution, but just know you can call it whatever. But tell me why you're going to double distribute this one and not the other 2 answer choices.
Positive, negative.
Because they're side by side. Doesn't matter what's in the parentheses, but if you have 2 parentheses back to back like that with nothing splitting them up, you're going to double distribute. So if I do 3 times 3 and 3 times -3i, what is 3 times 3?
3 times 3 is 9.
What's 3 times -3i?
Negative.
3i squared.
Nope. 3 times -3i.
Oh,
Negative 9i. Okay. We took care of the 3. Now let's do 3i distributed to each of them. So what's 3i times 3? 9i. What's 3i times -3i?
Negative 9i squared.
Negative 9i squared. Because 3 times -3 is -9. I times I is I squared. Now again, at this point, if you want to combine like terms, you can do that. But like I keep saying, I replace I squared with -1 first. That's just personal preference. But I had some kids in Storm that were working on the homework, like these are kids from first period, and they wanted to combine like terms here. You can do that. I just don't. So I'm going to put 9 minus 9i plus 9i minus 9 times -1. Because again, it is my personal preference that I like to replace I squared with -1 first. Now, since I did that, I'm going to have to recognize here that I need to do -9 times negative 1. I'm going to bring everything else down because so far that has remained unaffected. And negative 9 times negative 1 gives me positive 9. Now, here is where I will combine like terms. So what's one pair of like terms that we have?
9,
9 and 9. What does that give us?
18.
18.
And then one-
Okay, 9 and 9 gives us 18. Now, the negative 9i and the positive 9i are also like terms. But what happens when we do negative 9i plus 9i? They cancel out. So, if 18 is our simplified form, is that real or non-real? Real. So, out beside of this expression, I want you to fill in that real bubble. Okay? Fill in that real bubble. Okay? Now, I'm going to do this next one in blue. Okay? The second expression that we're given is 3 plus 3i plus 3 minus 3i. Now, in front of that first parentheses, we don't have anything. So we don't have to distribute anything to it. So I'm just going to drop these parentheses. And I'm going to bring down the 3 plus 3i. Now, technically, this is a positive what? 1. If I distribute positive 1 to 3 minus 3i, does that change anything about it?
No.
No. So I'm going to bring down plus 3 minus 3i. And if you need to make a little note that you're distributing that 1 and it stays like that, then that's fine. Now, if we combine like terms, 3 and 3 gives us 6. And what's 3i minus 3i give us?
Yes.
Yeah, it cancels because positive 3i, negative 3i cancels. So again here, our simplified expression is 6. Is that real or non-real?
Real.
Real. Because it doesn't have an imaginary part. Okay. Now, I'm going to do the last one in red. But for the last one, we have 3 plus 3i minus 3 minus 3i. Again here, since there's nothing in front of this first parentheses, we can just drop them out.
Yep.
Because they're technically not necessary. So I'm going to have 3 plus 3i. Right here, this is technically a negative what?
1.
1. If I distribute a negative 1 inside of parentheses, it is going to affect it because negative 1 times 3 is negative 3, and negative 1 times negative 3i is going to be what? Yeah, I just want to say it, positive 3i. If I combine like terms, what happens with 3 and negative 3? They cancel each other out. And what's 3i plus 3i? 6i. And remember, it's not 6i squared when you're combining like terms. That's when you're multiplying. So it's just 6i. Is that real or non-real?
That's non-real.
It's non-real. I'm going to give you a second to get this down. And then we're going to do the final, I think it's the final example. Example 7. Is that the last one I have you guys?
Yes.
So that's going to be the last one we do. Beside of example 7, I want you to put HW number 8.
How many questions are there?
8. Okay. So out beside of this one, I want you to put HW number 8. If you think you can do this one, I want you to try. Because if you understood the last one, you're going to do fine on this. So it says, write the expression negative 10 minus 4i times 2 minus 3i in a plus bi form. Looking at what we did in example number 6, somebody tell me what we're going to do with these two parentheses. We're going to double distribute. Again, we know that because there's nothing splitting them up. Okay? There's nothing splitting up your two parentheses. You're going to double distribute. So I'm going to do negative 10 times 2 and negative 10 times negative 3i. Negative 10 times 2 gives us negative 20, but what's negative 10 times negative 3i?
30 off.
Yeah, positive 30i, good. Because a negative times a negative is a positive, 10 times 3 is 30, and then we only have one I, so we bring it down. Now let's do negative 4i times each of these. So negative 4i times 2 gives us what? Negative 8i, because negative 4 times 2 is negative 8. Bring down that I. Negative 4i times negative 3i is going to give us positive 12 what? So positive 12i what? Squared, because negative 4 times negative 3 is 12. I times I is I squared. At this point, I'm going to replace I squared with negative 1. Because again, you guys know that that's my personal preference. If you want to combine like terms and then do that, you can. But I'm going to replace I squared with negative 1. So I have negative 20 plus 30i minus 8i plus 12. And then I'm substituting negative 1 in for I squared. Again, be careful here that you're putting parentheses around it and you're multiplying it. Every single year, I have kids that just put minus 1 at the end, and then they would put positive 11 there. You have to multiply it. So 12 times negative 1 is going to give me negative 12 at the end. And then it's just a matter of combining like terms. So somebody tell me what's negative 20 minus 12? Good, Alyssa. Negative 32. Somebody tell me what's 30i minus 8i?
22.
Positive 22i. I'm going to come around and give you guys the homework. Honestly, I just want to say we're really proud of you guys. It's for a Monday, and it being a brand new concept, you got this really good. And plus, you didn't freak out that first 3 minutes. I'm going to give homework to the first person. Once you get it, put your name on it. Now remember, children, tomorrow we're going to have 15 minutes at the beginning of class to do what? Finish the homework. Finish it. Not get it started. Finish it. So you need to go through tonight. Do what you know you can do for sure. And then tomorrow, when you come in here, ask for help on the things you need clarification on.